Okay, good.
Okay, sweet. We'll start. Hi, I'm Ellie Kurzrock. I'm a fourth year BMed and I'm doing a minor in psychology. So I'm really interested in kind of the interface between like neuroscience and BMed, which is what really drove me to become interested in this project because it's really like a solid combination of both of those two.
And I'm Drew Evans. I'm a third year electrical engineer, and I've been doing work in the past on PCB design and some sensor selection. And so that got me interested in the electrical side of what this project is going to do.
Okay, so basically the problem statement is that approximately 1.2% of the US population has epilepsy, which is basically the disorder that's just characterized by seizures. And so a lot of people that have epilepsy are able to manage it with medication, but approximately 30%, which is pretty much a third of people that experience epilepsy, theirs is medication resistant, which means they really just don't know when they're going to have a seizure, and it can happen at any like unexpected time. And so the risk of a seizure can really just limit a person's independence and their ability to like live alone, hold down a stable career, and even like have a driver's license. So being able to predict when a seizure is going to happen would be a huge positive benefit to their lives.
So in terms of existing solutions, for prediction, there's really only two options, either seizure alert dogs or invasive procedures. So seizure alert dogs are relatively new in terms of what service dogs can do. They haven't been around for that long. And some owners just ended up having their dogs, or some owners have reported that their just domestic dogs, non-trained, have alerted them to seizures. That and continuing that with actual seizure alert dogs, there have been some recent studies on them, and the studies have shown that the dogs can predict a seizure somewhere between 5 seconds and or somewhere between 10 seconds and 5 hours before the owner experiences a seizure, which is a huge range, but it was a survey of owners and their seizure alert dogs. So it had a big variation, and they could predict with 70 to 85% accuracy. And then another study was done on whether or not trained seizure alert dogs can detect the scent of a seizure on their owner's breath and sweat. So they took breath and sweat samples from just random seizure patients, and then put those in a controlled lab environment, and the dogs alerted to them with very high accuracy. And then the other solution for prediction right now are invasive procedures, which all involve implants. Most of them go into the brain, and that has some obvious downsides.
So the other option is for existing solutions are to detect them. So basically that monitors when somebody is having a seizure, but it can't give them any warning ahead of time. So the four main categories that are on the market now are mattress devices, which is basically like this layer that goes underneath the mattress, and it measures, I don't know if you could see my mouse, but it's the bottom left picture. And it measures movement in bed. And so then it can track if someone's having a seizure. And then the other one, which is not as high technology, is a sleep monitor, which is basically the same thing as a baby monitor, and it can sound an alarm if it senses that someone's having a seizure. And then there's a motion device, which is the top left picture. And so it's basically something like it's big, it's not like discreet, that someone puts on their arm, and it can measure their muscle activity, because muscle activity is going to be different when someone's experiencing a seizure. And so this records the activity. And then the one that we're focusing on the most and trying to model our device on is a watch device, and the main company that's on the market is called Empatica. And so it measures the electrodermal activity. Um, and it monitors seizures, and it can alert specific like pre-programmed numbers when a seizure is happening, and you can go back on the app and see statistics about the seizures. And so the encompassing science behind all of these is that there's changes in the autonomic nervous system that have been reported during seizures. And so some of those are a change in heart rate, a change in temperature, and then an increase in electrodermal activity, which is basically the charge on the skin. So all of these devices act upon those signals, but so far they've not been able to predict before the event when a seizure is going to happen.
So our project is going to focus on prediction in a non-invasive way, and we're planning right now on trying to use odor detection to accomplish that. And then we're going to eventually try to work that into a wearable device, hopefully for the wrist. We're still in the research phase, so odor detection is what we're leaning towards right now, but we've also taken a look at electrodermal activity, but it looks like so far electrodermal activity has been studied much more than odor detection, and they haven't been able to use it to predict seizures.
So our project timeline is very tentative right now. It's depending on how long in this year we're going to be doing virtual classes, and whether we're going to be able to access like on-campus workshops. But so right now, what our plan is for fall quarter, we're planning on doing research, researching the existing technologies and getting enough information that by the end of the quarter, we can make a specific decision about where we want the direction of this project to go. And then starting off in winter quarter, we're hoping to collect samples of sweat from people with epilepsy and use that to do mass spectrometry. And so basically there's a mass spectrometer and a gas chromatograph in the chemistry department at school. And in it, you can identify the specific components of an odor. So we're hoping to use that and to be able to identify the specific seizure protein or whatever of the odor that the dogs are smelling. And then once we identify that, we're hoping that'll be the end of winter quarter. And then for spring, we're going to focus on selecting a sensor, a sort of like electronic nose, and ordering one and testing it and teaching it to the smell that we want it to identify.
So how would you guys fit into the team? First of all, we're open to anyone joining the team of any experience level in any year and any major. And that being said, we're particularly seeking experience in biochem and chem because of the testing on the sweat that we're going to need to do, and then electrical sensors and software-based signal processing. If you have any experience in that, I think that would come in very handy. And then as far as our team like structuring is concerned, I think we're going to try to keep it very collaborative within our team. This is somewhat dependent on how many people join and what everyone's experience levels are. We may at some point end up splitting into sub teams, but right now I think we'll probably work as one group within the seizure prediction device. And Ellie and I can help teach you guys if you want to learn more about electronics or neuro BMed stuff. And I can teach you about PCB design, printed circuit board design, if we ever get to that stage, or if you're particularly interested in it. And other than that, we have some just other expectations on the next slide for what fall quarter is going to look like.
So as we said, fall quarter is going to be research focused, mainly because research is the first step in doing any project, and also because we're very limited to Zoom. So we're going to be examining studies that have already happened and hopefully contacting the people that have run these studies and contacting people from the industries of the devices that already exist to monitor seizures. And so with that, we hope we can get some industry collaboration, which would really benefit our project. Um, and so then the weekly work estimate, this is very estimated. Um, so we're planning on having about one like update meeting a week, which will take around 45 minutes. And then we're going to do one work session, which we're estimating is going to take 2 hours, but it's very up in the air. Um, the amount of individual work is highly variable. It depends on how many people are on the team and also what step we are in it. But we're expecting an increase in work near the end of the quarter because we'd like to put together a little report to present to the Medical Design Club board of where we are and where we want to be going forward.
So do you guys have any questions for us about really anything but our plans, our proposed designs, what we would expect from you, anything else about your involvement?